Good day, everyone. This is Professor Friday coming at you one more time. Today we are going to be verifying a couple of trigonometric identities. First one we've got for today is going to be verify the identity tangent of theta plus 1 quantity squared plus tangent of theta minus 1 quantity squared is equal to 2 times the secant squared of theta. The advice I always give to my students for verifying trigonometric identities is always start with the more complicated side. So we are going to start by making sure the pen actually writes. Start with the left side. Now, unlike regular old algebra, in algebra you're allowed to manipulate both sides. To verify an identity, we're supposed to start with one side and end at the other side. We can't manipulate both sides. Now, I'm also going to do my best to justify every single step that I make. So, we'll do some algebra and some trigonometry in black, and then we will write down what we did in red. So first thing I do is I notice that I've got two things added together that are squared and two things subtracted that are squared. That is just screaming for us to FOIL. So we'll express the first one as two factors and express the second one as two factors. There's not really a lot to justify in that step. So first outer, inner, last. First will be tangent theta times tangent theta, that's tangent squared. Outer will be tangent theta times 1. Inner is 1 times tangent theta. And then last will be plus 1. The next one, F, gives us tangent theta times tangent theta, it's tangent squared. Outer we've got tangent theta times minus 1. Inner will be the same. And then last we've got negative 1 times negative 1. And if we're going to justify that step, we could say algebra, or specifically we just use the FOIL technique for both of these. Now I see that we have some like terms in here. What I'd like to do is cancel a couple of the like terms. We have a tangent theta minus tangent theta and tangent theta minus tangent theta. Those are gone. That'll leave us with 2 times tangent squared theta plus, we've got a plus 1 and a plus 1, that'll be plus 2. To justify that step, we'll say we combine like terms. Or a bigger blanket statement could be that we did algebra. Now, taking a look at what we have now and where we're trying to go, this is what I refer to my students as eyes on the prize. We have this, we're trying to get to this. We have a tangent squared, we're trying to turn it into a secant squared. That just reeks of a Pythagorean identity. So first thing I'm going to do is get this down to just a single tangent squared by factoring out the greatest common factor of 2. Greatest common factor, 2. Now this takes exactly the form of a Pythagorean identity. This is 2 times the secant squared of theta. And for a justification, we'll say Pythagorean identity. Comparing that to our right-hand side up top, that is exactly what we're supposed to have arrived at. We'll indicate that the proof is done with a little box like this. Now, as always, this is not the only way to figure out this trigonometric identity, but it is recommended. So, hope this was helpful. I'll see you again soon.